Hello students, welcome to Learner's Planet and this session of chemical reactions and equations. In our last session, we discussed how to write a chemical formula or what is a chemical formula. To start with, I'll again read this definition of chemical formula. It is the chemical formula of a substance is the symbolic representation of the actual number of atoms present in one molecule of that substance. If you remember, in our last session, we discussed to write the chemical formula of sodium chloride. Now in the students, I'll tell you few more examples. Now here there is an example of oxygen. Now how to write a molecule of oxygen? Your oxygen is diatomic. What do you mean by diatomic? Diatomic means the one molecule of oxygen is made up of two atoms of it. So what will be the formula of a molecule of oxygen? It is O2. And students, remember, oxygen always exists as O2 molecule. You are never going to use single oxygen atom because it is highly unstable. Now just tell me why it is highly unstable. This is because oxygen requires only 2 electrons to complete its octet. Now tell me how many electrons are present in the outermost shell of oxygen? Just tell me, it is 6 electrons. So, when there are oxygen has got how many electrons? It has got 6 electrons. How much it requires to complete its octet? How many electrons more it requires to complete its octet? It requires 2 electrons. So, your oxygen atom is having how many electrons? It is having 2 electrons. Right? So your oxygen is having 6 electrons in its outermost orbit. How many electrons it requires to complete its octet? Only 2. So what it does? It becomes unstable and it combines with the another oxygen atom and forming an oxygen molecule. Right? So the structure of the oxygen is like oxygen. It forms a double bond with another oxygen. Now see, both the oxygen have completed their octet and then it forms an oxygen molecule. Now students, there are many elements which exist in diatomic state. Like your nitrogen. Nitrogen exists as N2. Chlorine exists as Cl2. Bromine exists as Br2. Tell me another example. But sulfur. Sulfur exists as SH. So these are the molecules which exist in diatomic state. Another in the pipeline is hydrogen. So now these atoms are existing in diatomic state. So while balancing the chemical equation or writing the formula, you are not going to change the atomicity of the elements. Like in an equation, if single atom is there, both the sides, it is wrong. So you must remember what all atoms exist in a diatomic state. Likewise, formula of one molecule of hydrogen is H2. Okay, what it shows that one molecule of hydrogen is made up of 2 atoms of it. Now the reason behind this diatomicity or your ozone is triatomic. What is the formula of ozone? Ozone is O3. Now students, why it is triatomic? Because again there are 3 atoms combining and forming that one molecule. So the reason for this is the instability of the atoms. Now let's discuss few more examples. Formula of one molecule of water is H2O. It shows that one molecule of water is made up of 2 atoms of hydrogen and 1 atom of oxygen. It's written there, the formula is H2O also. But how that formula is made? It would have been H3O, it would have been H4O, or it would have been HO. Why only H2O? What is the need of H2O? Now let's discuss this, how this formula is written. And there is another example of sulphur dioxide also. I'll come to it later. Let's first write the formula of H2O. Now students, say valency. For writing a formula, what we need to know is the valency thing. Now what is the valency? Valency is what? It is the actual number of electrons. It is the number of electrons participating for formation of a molecule. Now how these valencies are decided? You must have seen periodic table. In the periodic table there are what? There are groups. The elements are arranged in groups. There are first 2 groups, then the elements are on the left side. So you can see that the group number also decides the valency. Or making it more simple, I can say that the number of electrons present in the outermost shell decides the valency, outermost orbit, in the last orbit. The number of electrons in the last orbit decides your valency. Let's take example. Say, what example we can take is, let's take a first group. First group has got what? The elements of the first group are hydrogen, lithium, sodium, potassium, rubidium and cesium. So, what group these elements are present, students? These are present in first group. Now, you all must be knowing how many electrons are there in hydrogen. There is only 1 electron. How many electrons are present in outermost orbit of lithium? First tell me, what is the atomic number of lithium? The atomic number of lithium is 3. Now, how the electrons can be arranged? It can be arranged as 2 and 1. What is the atomic number of sodium, students? It's 11. How can you arrange these electrons? You can arrange them as 2, 8 and 1. What is the atomic number of potassium? It is 19. How could you arrange 2, 8, 8? Yes, tell me, what is it? And 1. So we'll do it till here only. Now see, there is one thing common in this group, that is all are having 1 electrons in their outermost orbit. Now students, if I talk of your second group of the periodic table, what all are the elements there? There is beryllium, magnesium, calcium, strontium, barium and radium, of course, that is radioactive. Now let's see how many electrons are present in the outermost orbit. Beryllium, what is the atomic number? It's 4. How these electrons can be arranged? It can be arranged as 2 and 2. Magnesium, the atomic number is 12. How can I arrange them? 2, 8 and 2. Calcium, what is the atomic number? It's 20. It can be, the number of electrons can be arranged as 2, 8, 8 and 2. So what is the thing you are observing in the first group and the second group, students? It is in the first group, the last orbit has single electron, that is 1. And in the second group, the last orbit has how many electrons? 2. So, what will be the valency of first group elements? I can write that their valency is equal to 1. And of the second group elements, I can write as valency is equal to 2. Likewise, depending on the number of electrons present in the last orbit of an atom, we decide its valency. Now, let's move to the p-block elements, or the elements present on the right hand side of the periodic table. Tell me, what are the elements present on the right hand side? I'll just take carbon. Now carbon, what is the atomic number? Atomic number is 6. How can we arrange these electrons? 2 and 4. So students, tell me, how many electrons are present in the outermost orbit? It is 4. So what would be its valency? It would be 4. Valency would be 4. If I am taking here nitrogen, so nitrogen, what is the atomic number of nitrogen, students? Just remember, try to remember, it is 7. How can I arrange these electrons? I can arrange them as 2 and 5. Now how many electrons are present in the outermost orbit? 5. Now students, just tell me, is it easy to lose all these 5 electrons? No. Rather, what it can do is, it can just take up 3 electrons and complete its octet. What do you mean by octet? Octet is 8 electrons. Every orbit should have 8 electrons. So, what better thing it can do is, it can take up 3 electrons and complete its octet. Now, as it is taking up 3 electrons, what its valency will become? Valency will be what? It would be -3. Why it is -3? Because it is accepting or taking 3 electrons for completing its octet. So, what will be your valency of nitrogen? Valency of nitrogen would be 3, or rather it would be -3. Likewise, if you proceed ahead, what all electrons are there? Tell me, what all elements are there? There are halogens. There is oxygen group also. So let's talk of oxygen. What is the atomic number of oxygen? It's 8. How can we divide these electrons or distribute the electrons? It will be 2 and 6. Again students, what will be the easier thing for it? Is it easy to lose all the 6 electrons? No, it can't lose. Why it can't lose? Because the nucleus has got protons, and those protons have got strong attractive force for the electrons. So it cannot lose all the 6 electrons. What it can do is, it can accept 2 electrons. So what its valency will become? What will be its valency, students? Valency would be 2. Now, or state you can write here, nitrogen also you can take its valency as 3. There is no need to use positive sign for valency. Or negative sign, sorry. There is no need to use negative sign for valency. You can just use the numbers. Now if I take another molecule, that is chlorine. You must be knowing about the halogens. That is, If I talk of chlorine, what is it? What is the atomic number of chlorine, students? This is the symbol of chlorine. Now what is the atomic number of chlorine? Try to remember it. What is the atomic number of chlorine? It is 17. So CHLORINE, chlorine, symbol is Cl, atomic number is 17. How many electrons you'll get in the outermost orbit? You are getting, let's distribute these electrons. I'll get 2, 8, 8. How many electrons? I have got 18. So the last orbit may, how many electrons I can have? Can I have 8? No, students, I can't have 8. So how many electrons I can have? I can have only 7 electrons. So if it's 7 electron, what would be the easier thing for this atom? What it can do? Can it lose all the 7 electrons? No, it cannot lose. Why it cannot lose? Because there is a strong force of attraction by protons on these electrons. Now it is not able to lose all these 7. So what it will do? It will gain 1 electron and complete its octet. So what will be the valency of chlorine? It is 1. Right, students? So what is my point telling you valencies for writing a formula? Remember, students, for writing a formula, the most essential thing is its valency. The valency should be satisfied. Now coming back to our slide of H2O, what I have told, hydrogen has valency 1, oxygen has valency 2. So that is crossed. Say if I write here hydrogen, its valency is 1 and oxygen, its valency is 2. Now the number of atoms in the molecule are crossed. So that is how many atoms of hydrogen you are going to take? 2. And how many atoms of oxygen you are going to take? Just tell me how many atoms of oxygen you are going to take. You are going to take 1. Okay, so your formula becomes H2O. Did you get how did I write the formula of H2O? Now let's take another example, that is of sulphur-di-oxide. Now in this case, what is happening is sulfur is combining with 2 atoms of oxygen. In this case, your sulfur is losing 4 electrons to oxygen, or we can simply write the formula as SO2. So let's take the example of this sulphuric acid. In sulphuric acid, what all are the atoms present? That is hydrogen, sulfur and oxygen. Now how are they forming the bond? So this is for the formation of formula of sulphuric acid. It's a bit higher level. You need to understand the oxidation states and other aspects of an atom. At this level, I'm not going to discuss the oxidation states. You just remember the formula of H2SO4. In your 11th, we'll definitely discuss the oxidation states, and then I'll tell you how to form the formulas of complicated compounds. Likewise, your nitric acid, the formula is HNO3. How many atoms of hydrogen are there? 1. Nitrogen 1 and oxygen 3. So students, the formula of these complex compounds you just remember, because a lot of things you need to understand for writing complex formulas. At this level, we'll study only simple formulas like barium chloride. If I'm taking this barium chloride, now just tell me students, what all are the atoms here? The atoms are of barium and chlorine, right? Barium, what is the symbol of barium? The symbol of barium is Ba. And what is the symbol of chlorine? Tell me, chlorine is Cl. Barium, where it is present, how many electrons are there in the outermost orbit? There are 2 electrons. So I can write here 2 electrons in the outermost orbit. So what is its valency? Valency is 2. What about chlorine? I have just now told you what is the valency of chlorine. What is the valency of chlorine? It's 1. How can they combine? You have to cross multiply the numbers. How many barium atom will be there in barium chloride? It will be 1 or 2. It would be 1. And how many chlorine atoms would be there? It would be 2. So what you have to do, students, is you have to just cross multiply the valencies. Now the formula of barium chloride will be BaCl2. What I have done is I have cross multiplied the valencies. I'll tell you another example. Let's take potassium chloride, the simplest molecule. KCl. This is what? This is potassium chloride. Now, why I have written KCl? You just tell me. This valency of potassium is potassium. The symbol of potassium is K. Its valency is 1. Likewise, valency, I have told you what is the valency of chlorine. We have just now discussed valency of chlorine is 1. Now what is to be done is you just cross multiply the valencies and you will get this. What are you getting? You will get this potassium chloride. I'll form some different molecule like carbon tetrachloride. Carbon tetrachloride. Now what does this mean? Carbon. What all atoms will be there? Carbon and chlorine. Tetra. Tetra means what? Tetra means 4. So it would be carbon tetrachloride. Valency of carbon is, just tell me, what is the valency of carbon? Valency of carbon. How many electrons are there in the outermost orbit? It is 4. So valency of carbon would be 4. Valency of chlorine we have done and it is what? 1. Cross multiply the valencies and you will get CCl4. Likewise, if I write PCl5, now you tell me what will be its name. What would be its name, students? P. P is the symbol of phosphorus. Cl is the symbol of chlorine. 5 means what? Pent. So it would be phosphorus pentachloride. Again, valency of phosphorus can be +5 or -3. +5 for losing all the 5 electrons because it is a bigger atom. Nitrogen is a smaller atom. It cannot lose. But phosphorus, the size of phosphorus is big. So it can lose all the 5 electrons. Now here the valency of chlorine is 1 and the valency of phosphorus is equal to 5 and valency of chlorine is equal to 1. So cross multiply the valencies and what you will get is phosphorus pentachloride. So likewise, students, for writing the chemical formulas, what you need is the valencies. The valencies must be satisfied. Each and every atom should have 8 electrons after bonding. Don't worry, we'll discuss bonding in your next class. That is in 11th, there you have a complete chapter on chemical bonding. We'll discuss it there. But for now, you just remember how to write the chemical formulae. Now coming to my slide again, you have to just remember the formula of complex compounds like H2SO4 and HNO3. This is the way how we wrote the chemical formulas. You can take as many examples. Okay, just remember that the valencies are cross multiplied. Coming to my previous slide, I can take one more example here, that is of AlCl3. Now what is this AlCl3, students? Al is a symbol of aluminium. Write it in your copy. It would be better. You take a notebook, just start jotting down what I am saying. Okay, AlCl3. Al is the symbol of aluminium. Cl is the symbol of chlorine. Now what this formula suggests you? What it suggests? It suggests that the valency of aluminium is 3 and the valency of chlorine is 1. You cross multiply it and you have got what? AlCl3. Now quickly check out and write the formula of hydrogen sulfide. I repeat, hydrogen sulfide. Now students, what all atoms are present here? Hydrogen and sulfur. Got my point? Now write its valencies. Hydrogen has valency 1 and sulfur has valency 2. So cross multiply their valencies and what are you getting is, what are you getting? It is H2S. Okay. Now this is the way you can write your chemical formulas. Fine. Now students, I hope you can write now the chemical formulas. It's better you practice. Practice to write more and more formulas and you'll be perfect in it. Okay? Now, after discussing the symbols and formula, why we need to write the formula? What is the need? What is the need to take all that pains to write the formula? This is because every atom is stable when it has got 8 electrons in its octet. This 8 electrons it can gain either by exchange of electrons, either it can gain electron or it can lose electron, or it can share the electrons with the other atoms. Getting my point? So when it is sharing the electrons, every atom is having 8 electrons. Now when the octet is complete, your atom becomes stable. Fine. Now applying these symbols and formula to form a chemical equation. Okay. Now for this session, I would stop here only and I would expect you to practice as many formulas as you can so that we are able to write chemical equations. Okay, so in the next session, I'll tell you how we write chemical equations using symbols and formula. Fine.